at number 8. In number 8, they ask you to find P of replace, Viola. Every place there is an N with what? With 4. So every place where there's an N, I'm going to put in a 4. Now, when I do it the first time, I'm probably going to write the 4. Can I put 4 plus 1? Yes. Could I put 5? Yes. I have 4 plus 2. 4 plus 2 gives me 6. All divided by 6. So I have 4 times 5 times 6 divided by 6. Well, 6 divided by 6 I know is 1. And this equals 20 as I look at question number 8. Question number 9, very similar. In question number 9, this time what they're asking us to find, though, instead is they're asking us, and you got to do a little squaring of your numbers. So in number 9, same thing, you want to do it. And this is what you should have done for questions 4, 5, 6, 7. You should have replaced the N in this place. And this time, as we take a look at this one, we're asked to put our N in as a 3. So we are going to put the 3 in. And as we are looking at that, I don't know why I can't get to this page in my workbook. All right. So if we are taking a look at that, we're going to say Q of 3. So Sonia, tell me what to write down.
3.
Nope.
Or 4 times 3.
4 times 3.
And then 2 times 3 squared minus 1.
Now, we got to follow the order of operations, right? So in my numerator, 4 times 3, I can simply multiply that. My denominator, Jacob, what's the first thing I have to do in that denominator? Can't multiply first. I'm not going to take 6 and square it. I want to square first. So,
Okay, so 3 times 3.
okay, which gives me 9 times 2 minus 1. That's how they got 12 17ths as we were taking a look at that one. And it said my first term is 1. And we were asked to do the first 4 terms, right? So a sub 1 is 4. What does a to the n minus 1 mean? What does n minus 1 tell us? It tells us the previous. So everyone, a to the n minus 1 tells us what? Previous. I didn't hear, some of you didn't say it. A to the n minus 1 means what? The previous. So you've got to make sure. This just means the one before. So I'm going to find a sub 2. That means I need the previous term. Oh, it was a 1. What am I doing to it? I am squaring it and adding 1. 1 squared is 1, plus 1, 2. Right? This is 1 plus 1. Oh, I want to find a sub 3. I'm taking the previous. Allie, what was my previous? 2. I'm squaring it and adding 1. 2 squared, Allie, is? 4 plus 1. So I get 5. I want to find a to the 4th. What am I going to do, Ben? The previous was? Okay, what was my previous term? Not the third, the 3. I want to use 5. What am I doing then? Squaring it and adding 1. Which gives me? Does that make sense? So they get pretty big pretty fast, right? So as they're increasing as we look at this. All right, so number 17 says write a recursive formula. You have to do this on the test. I was just making up my answer key for the test. It's next week. So the recursive formula, you always want to start with this bracket. You're going to tell me always the first term, and then you're going to tell me a sub n. When you start the a sub n, you're always telling me what happened to the previous term, right? So this is always a to the n minus 1. Someone said, why do you use a? You could really use any number or letter for the sequence. We use this one. My first term, if I was looking at this, Sophia, is what? A 5. And then what's happening each time? We're doing what with it, Griffin? What would you say? We get 5 to 10, 10 to 20, 20 to 40, 40? Multiplying by 2. So I'm taking the previous term and I'm multiplying it by 2. Oh, I didn't write it that way, Mrs. Thompson. I put a sub n equals 2 times, does it matter if you put the 2 in front or behind it? Doesn't matter, okay? But you do have to tell me this part, for n greater than 1. Why? Because you already told me the first term. So this only works for the second, the third, the fourth, the fifth term. Because the first term is already defined. Okay, so you got to make sure you have that either way as you're looking at that. This is the recursive formula. You have to write it recursively on your test. This is section 4.7 in your textbook. So you need to be able to define, knowing that there's going to be a common difference. The common difference when we did our first part, linear, that was our slope. Okay, so when we were doing our equations, that was our slope, our rate of change, right? So in equations, we had a slope. In sequences, we call it a common difference. That common difference between two terms, that's how you find the slope. So when you're given two terms, you can always think of them as an xy and an xy. And what's super nice about that is how do you find the slope? Slope is always the change in y over the change in x. So to find that difference, we can always use slope from the last unit. So we're going to be thinking about inputs, outputs. We're going to be talking about the explicit formula also today, which is really slope, point slope. Point slope is explicit. If you have point slope down, you're just going to go, oh, this is so exactly point slope is what the recursive or is what the explicit formula is. So when we think about that recursive, that's what you had to do today. You always have to tell where you started. So you have to always say, oh, it's A1. And then you're kind of building on it. So recursive formulas are used to generate a term in a sequence, knowing where you start, and then you're usually going to add or subtract to get that next term. So when you think about an arithmetic sequence at the bottom of the next page, if I was looking at this one, some sequences are composed simply of random values, while others have a definite pattern. Arithmetic sequences always have a repeated addition or subtraction. That's our constant, often called our common difference. This represents the D back here in our equation. So the D is really the common difference. It's what you are adding or subtracting, right, to get the next number in our sequence. So if I was looking at this sequence that's written right above here, and we are asked to write this one, I could write this one as A sub 1 is equal to what, Grace, as I'm looking at that? What's my first term? 1. Then I'm going to put A sub n is equal to the previous A to the n minus 1. And as I'm looking at that, Larissa, what happened each time? So plus 3, and then we're going to put for n greater than 1. And you're done. That's it. And what? Adding 3. Common difference is to add 3. They asked us to write the first 3 terms. So we're going to take negative 24, right? We're going to add 3, which gives us negative 21. Keep going. Negative 18, right? Negative 15. Negative 12. Okay? Down here, it says identify our common difference. Common difference in this one, Jacob, would be 10. Oh, yeah, we are definitely adding 10, positive 10. So then it says write the recursive formula. So as I'm starting with this one, Viola, I'm going to start with A to the 1 equals what number? What's my first? Negative 5. Then, Griffin, I'm going to write A to the n is equal to my previous, right? That just means previous, right? And then what are you doing? Adding 10, plus 10. For n, or when n is greater than 1. Done. That's it, right? So, as we take a look at that next page, Again, you guys can watch these. It says, oh, find the recursive formula to a sequence where x is written as this equation. Y equals negative x plus 2. Now, what do we know about this equation? It's in slope-intercept form, right? And the slope is what? Negative 2. What does that mean? Slope of negative 2. It means that we are subtracting 2 from each number as we increase our x by 1, okay? If I asked you my y-intercept in this equation, you'd tell me 0, 3, right? Now, someone said, why do you put the 0 with it? Because it's not our first term, right? It's the 0 term. Sequences never have a 0 term. They start with 1. So, let's plug in 1 into this equation. So, if we are going to generate this sequence from an equation, you can't start at 0. That's the number before we write the sequence, because sequences always start at 1. So, if I plug in 1 to this equation, my first number would be, I'm going to go y equals negative 2 times 1 plus 3, which gives me 1. My first number in the sequence is 1. What's the next? I'm not going to write it down here because I need to write my recursive. So my first one was 1. Now I'm going to subtract 2 from that, right? So the next one should be at negative 1. The next one should be at negative 3. Then it should be negative 5. Oh, could I check that the fourth term, could I check that? Sure. How do I check it? I just simply go to y equals negative 2 times 4 plus 3. Negative 12. Negative 8. Not 12. I'm thinking 3. Negative 8 plus 3. Yeah, that gives me that term, right? So they always have to check. Why did I use 4? This was the fourth term, right? So I can go back and forth and check those. All right, Prasha, start us out. We need to write this as a recursive formula. A sub 1 was what?
3.
Wait, what's my first term that we saw in our sequence? 1, right? Okay. Sonia, A sub n. What's happening to our previous term? So how do I write previous?
A1
Okay. And what were we doing to that every time? Did we add 3 each time? Subtracting 2. That's my common difference. Minus 2. When n is greater than 1. Okay. Why is our first term 1, not 3? The y-intercept. And the key thing that I want you to write down from this, the reason it's not 3 is that is the 0 term. So I'm going to have you write this question. Why is the first term not 3? Our y-intercept. And the reason is that's the 0 term. And sequences don't start with the 0, they start with the recursive sequence. The 7th term is negative 45, and the 11th is negative. So we're going to write this as 7, that's my 7th term, that's my x, negative 45, that's my y. So this is where I talked about thinking of these as an ordered pair, because you're going to find the slope. The other point, they tell us, is the 11th term. Again, that's my x, and negative 69 is my y, as we're thinking about that. So the first thing it says, find the common difference of slope. Oh, going back, Ben, what do we remember slope is? The change in what? Change in y or change in x. So then if I am subtracting, which one do you want to start with? Okay, negative 45 minus the negative 69. And then in my denominator, I have to have 7 minus 11. So as I'm taking a look at this one, I'm going to have in my numerator, this really becomes a plus. And I have 24. Does that sound right? Positive 24 over negative 2. My slope is negative 12. No, not 2. This is gonna, no one's gonna correct me. Should be what, negative 4. Correct me. I don't take any offense to that. So 24 and negative 4, which leaves us with negative 6. Okay? So, first thing it says, what's my common difference? My common difference is negative 6. I need the first term. So when I'm thinking about the first term, I'm going to start with point slope form. Oh, I'm going to go general point slope. Y equals m x minus x1 plus y1. I know, Allie, what the slope is. So I'm going to use y equals negative 6. We need to pick an x point. Viola, do you want to go with 7, negative 45 or 11, negative 69? Because that's the only information we know. 7, negative 45. This is the one we're going to use. So we're going to put x minus 7 plus a negative 45. Now, at this point, I could use the distributive property and multiply this out. So let's do that just to make sure, because you have to do that on the test, right? So we got negative 6x plus 42 plus negative 45. Slope-intercept form of this equation is negative 6x minus 3. Correct? By adding like terms. Okay? They said we need the first term. What do I replace x with to find the first term? X has to be 1, and I'm going to find y. Oh, what was my equation? Negative 6. Could I have done it right here? I could have substituted in 1 in here and solved it. Some of you, it's easier in slope-intercept form. So it's negative 6 times 1 minus 3. My y-coordinate is going to be negative 9. So, once I know the first term, right, once I know it's 1 comma 9, I can now really easily, and I knew my slope, common difference was negative 6. I'm writing the recursive formula. Sophia, I'm going to start with a sub 1 equals, yeah, this should be negative 9, right? That should be negative 9, thank you. Negative 9. Then, Sonia, I'm going to put a sub n is equal to a sub n minus 1. That makes sense?
Yeah.
And then what? Larissa, help me out. What is happening? We always need to put plus or minus our common difference. What was it? Add 6? I could go add negative 6 or I could go minus 6 here. So this is always the previous plus the difference. Okay, our difference was a negative 6 for n greater than 1. So if we are taking a look at all right, so if I am taking a look at this table, as you read the question, so we are owing our parents money, and we're looking at each month it's going down, right? So $650, $620, right? Each month we're taking away $30, okay? The point we really care the most about is the first point. So when we take a look at these, our first point right here is at 620. So it says, let a sub n be what you owed. Complete this table. We're going to do a recursive formula. So if I'm doing the recursive formula, you could put yours in the box. I'm just going to do mine right here because it's easier to put it right next to it. I am going to start, Viola, with a sub 1 equals what? 620. Don't want to use the 650 that we started with. A sub n, Griffin, is going to equal careful, a to the previous one, and then what are you doing? Minus 30. For n greater than 1. Page paper if you're in either of their English classes. Each night you decide you're going to write 3 pages. Write a recursive formula to describe the pages you have left. So, one thing sometimes I think is helpful is think of this as X and Y, as this is the nights you're dealing with, right? And this is the pages you have left to write. Well, you just got to sign the paper. That's like the 0. You had 27 pages to write, right? But after the first night, how many do you have left to write? 24, right? Because you took off 3. And then the second night, you'd have 21 because you wrote 3 more pages, right? So the most confusing thing is that people want to start with A1 as 27. But if we are writing it, Prasha, want to start me off?
A1 equals 24.
Yes.
And then AN equals A to the previous thing.
A to the n minus 1, I like it.
Minus 3, and then
Okay. Questions? Because is this an arithmetic sequence? Meaning, are we continually adding or subtracting? And you look at the numbers and you go 9, 27, 81. What did I do to 9 to get 27? Multiply by 3. So is it arithmetic? No. It's actually going to be what we're going to call later geometric. No, because we're multiplying by 3. Not adding. Right? There was not an addition or subtraction. Okay? All right. So it is important that you know that this is 16 ounces in 1 pound. Okay? And it says each morning he uses 3/4 of a cup, 3/4 of an ounce to brew his coffee. How many ounces of coffee does he have left after the first morning? Okay? So if we're thinking about this at 0, right, when he bought it, he had 16 ounces. But on day 1, what does he have? He has how much? He's used 3/4, so we're going to have 15 and 1/4, right? You used 3/4 of an ounce, right? Does that make sense to everyone? This is important because we don't start at 16. That's like the 0, right? So that's like the previous. So it says write a recursive formula when we go to do this. Oh, now I know A sub 1 is 15 and a 4. Could you use 15.25? I don't care. Now do I know how to write the next part as you are looking at that? Okay. When I look at this sequence, it says they donated money, $50 would be donated and 5 every month. This means my first term was 50, right? Then what happens? Oh, they donate, right? So I might want to list a sequence sometimes because then that's going to help me to write my recursive formula as you are thinking about those, okay? As you look at the bottom of this page, questions at all as you're looking at those?
why does it sometimes say you want to put like 4 and sometimes you want to put 1?
I'd take it either way. I really don't care. I think they usually use then or when n is greater. It doesn't matter. When, for, and if you don't want to use either word, just tell me n greater than 1. I'm good with that. I don't know how picky your Algebra 2 and upper level math people will be at that point, but at that point, you can change and adjust to them. I don't care that much, okay? All right, let's look at that second page. The second page, as you're looking at the homework, 11, they're just saying circle the sequences that are not arithmetic. And what I would like you to do is think, why is it arithmetic or not, right? Number 12, as you're looking at those, 12, 13, 16, 17, questions. Oh, yeah, let's look at number 16. It's kind of like that one we started with slope. This one you have a lot of work to do, okay? This one you have to first find the slope. Then you have to go to point slope. Then you have to find the first, when x equals 1, what is the y? It's exactly like the example that we did. So turn back and look at that one in your notes, right? Turn and look at this, because this is the information, and I'm not going to do the problem, but it says, in the steps leading to a shift, the third step is 52 inches. So 3, 52. The third, this is my step, right? This is how many inches. The third step, 52 inches above the water. The fifth step is 63. That's another ordered pair. The fifth step is 63. Assuming the steps have equal rise, how much is the ninth step? So you could do this. You could find that slope, that rate of change. That's going to be pretty easy. Do you have to go to the point slope form and do this? Or could you just go, oh, that common difference, and go how many more on to 63? 4 times that, right? So you could do it that way. You don't have to. What we are looking for is the ninth step. So you could do point slope, but you don't have to make it that difficult, right? You really have to find that common difference. And we get into these a lot more with that next unit. So